Hello, welcome everybody. Thank you so much for coming out. I mean, ahoy! Shouting into the microphone, that's always great. My name is Aji, that's a hard J. I've been a professional developer since 2016, but if you count GeoCities, I've been putting code on the web since 1996. Anyone in the room not yet born in 1996? Hands? A couple of you. That's awesome. I'm so glad you're here. I am regretting that I asked that question a little bit, though. So I do never really know what to say during these intros, so how about, in 4th grade, I got the lead in the school play of Mice and Mozart, where we told the life story of Wolfgang Amadeus Mozart through the eyes of a family of mice that lived in his walls. I played Mozart at 9, and I've been trying to relive that glory ever since. So I'm going to take a guess that we're on the same page about something. I'm going to assume that everyone here agrees that testing is important and that test-driven development can be massively beneficial. You're here at a software conference of a community that overwhelmingly appreciates automated testing, and you came to listen to your TDD treasure map, which might just imply that TDD is a kind of treasure. So I'm going to skip the arguments that try and convince you of the benefits of robust automated tests that verify your code is working properly, defend against regressions, support refactoring, act as living documentation, and provide design guidance. And although I didn't really understand the nuance at the time, that was certainly the feeling they tried to instill in us at my coding boot camp. But we had so little time. I graduated having never written a test without feeling the benefits of a good test suite. Plus, it seemed like a paradox. Write the thing that verifies the code that I will have written before I am going to have written the code that I will have been about to write? Yeah, sure, let me just jump into my time machine and take a look at that PR I'm going to put up tomorrow. Testing first can be difficult. That's true for seasoned sailors, but even more so for those newer to this career when it's a challenge to even reason about what code to write at all. How was I going to make it out of this mess? Like Archimedes in the bathtub or Newton and gravity, we need a compelling yet apocryphal story of discovery to go with it. So, scratching my head over this problem, I wandered over to my bookshelf that has all of my jobby-job career-type books. There's Sandy Metz's Practical Object-Oriented Design in Ruby. There's Atul Gawande's The Checklist Manifesto. Wonderful tomes that have set me on the path when I've needed them before. Wait. That's Robert Louis Stevenson's Treasure Island. How is this on this shelf? I'm the child of a librarian. This is so embarrassing, misshelving happening in my own home. Oh, but it dawned on me, of course this is here. Of course, because treasure maps. Okay, flowcharts. But think about it. A treasure map is a flowchart. Sure, one of the core strengths of a flowchart is the branching, the logic, being able to map out decisions that lead to different outcomes. But Stevenson's Captain Flint only wants the happy path that ends in doubloons. If we fill out the map, we put a decision branch here at the edge of this dense jungle. Without the map in our hands, we'd be lost and 404 not found. One way lies treasure, and the other to an encampment of rival pirates and 409 conflict. A decision here, and east means treasure, but west means eaten by crocodiles, and just like that, the whole crew is 410 gone. The rest of you need to brush up on your HTTP status codes. Not only is a flowchart useful for retracing your steps to your long-buried, ill-begotten gains, but one of the most helpful artifacts for understanding the control flow of a system and invaluable documentation for new team members. It's a kind of visual pseudocode. Think about all of the low-code and no-code solutions that are built on flowcharts as a UI, because they're so simple to understand, but potentially powerful. We can leverage that same strength as a shared language to build understanding between technical and non-technical team members and stakeholders and get buy-in from the business in a way that we never could with code. But no longer will the usefulness of this tool stop at the code's edge. We're going to learn how to directly apply it to writing tests and eventually code. So consider yourselves hornswoggled, ensnared into being my crew aboard the good ship Capybara, en route to the promised land where testing before you leave harbor can be smooth sailing. Before this half hour be over, we'll raid the ship of knowledge and you'll have new techniques of your own to boot. I do want to apologize for that accent for everyone watching who is a 17th century Caribbean pirate. Sorry, privateer. A chart can relate fairly directly to code, serving to mimic the control flow of an app, but how it relates to testing might not be as obvious. We'll use a pretty common situation of a Rails controller action to demonstrate how we can take a handful of acceptance criteria to a flowchart, turn that into test rigging, test code, and application code. A couple of quick caveats and definitions to simplify our upcoming parlay. When I say feature, I mean that to be any unit of work, be it a whole feature, a bug fix, partial implementation, whatever. I'll stick to saying feature for brevity. There's also probably an actual term for it, but when I'm talking about a test suite's rigging, I mean the describe, context, and it blocks that make up the tests. Like here, these lines with the descriptive strings and the levels of indentation that show how they relate to one another, that's what I'm calling the rigging. And although this process will work with any testing library, Ruby or not, my examples are going to be in RSpec because, as we all know, it is a pirate's favorite testing framework. The app our team is building is called Pirate Cove, where freelance freebooters can list their available skills and rating resume for captains looking to round out a crew for upcoming misdeeds. Sorry, adventures. Our app has users. We call them pirates. Pirates have profile pages. It's off-the-shelf Rails resource routing with the standard CRUD actions. This afternoon, we're pairing, all of us. Don't worry, I'll drive. And we've picked up a ticket with a new user story. And it looks like it's to implement one of those CRUD actions. As a pirate, I should be able to fill out the form on my profile page and submit it to change my information. The acceptance criteria, phrased a different way, so user can update a pirate's information from the profile page. There are actually two eventual acceptance criteria or requirements on this ticket, but we're going to start with just the first and pick up the second as we go. So we're going to begin with the action that we know is going to take place. That's typically a user acting on the system. And here, that's our pirate submitting form data. Standard flowchart symbols have start and end points as rounded shapes. So we'll start with that core action at the top center of our workspace. When that gets submitted and action occurs on the back end, we're going to save that data. And how do we resolve? Well, we show the updated information with a redirect to show. This alone right there, that could be the happy path of our feature. We know it's going to get a little more complex, but at least it's enough to write the matching rigging. Begins with a user action, some back-end work, and feedback for the user, beginning, middle, end. Now at the top of an RSpec file, we get something like this to start, but everything we're doing is going to be under patch update, so this is the last time we'll see this to save the slides getting a little bit too cluttered. Right away, I can see two outcomes that we expect will happen after form data is submitted. By Rails convention, redirecting to the pirate show page, and the only way that the pirate show page is going to have the proper information is if we also update the database to reflect changed data. This doesn't mean that every bubble in the flowchart needs to be tested, and we'll see that coming up. But in this case, we're testing more than just the very end, but also any action that changes something outside of our current test subject, a side effect. Our test subject is the pirate's controller. This makes a change in the database, way outside the controller. That's a result that we want to guarantee will happen to the best of our ability, so we'll protect it with a test. That way, if anyone ever comes along and makes a change that affects that outcome, even if the redirect still happens, we'll have feedback that an expected result has been affected. That's our tests preventing regressions. Now, the other piece to our test rigging are context blocks. The it blocks are going to match up to the end results, the effects of the action, and the context will correlate to the setups that exist. Those are found by following each individual path through the chart. Pretty easy at the moment. Right now, we've only got one path through the flowchart. It might make sense to wrap those two it blocks in a context block. I don't think we actually gain anything by doing that. It's the only context that exists, and it's already wrapped in that patch update describe block. So personal preference, but I'd leave it off for now. What else this indicates by being only one context is that our setup for these two tests will be the same. Each individual path through the chart will have a different state when the action is performed. We're focused down to a level where there is only one action. And most of the time that you're building out tests, that's how it's going to be. Maybe different granularities, sometimes different params or callers, but one single inciting action. In the ideal state, when you're focused on testing just one action, the only way to take different paths through the chart is with a different beginning state or different params to that action. So we're still here. We kind of know that it's not going to stay this simple, and this is a position you might find yourself in pretty often. You know that there's more looming, but it hasn't actually shown up quite yet. So let's not complicate it. I'd rather start moving forward on something that I'm sure of, naive or not, rather than speculate and end up down an irrelevant rabbit hole. Yes, I said irrelevant rabbit hole. Okay. We've got some ambiguity, but we've also got something concrete. So let's move forward on that. I'm confident enough that what comes next will reveal itself as we go through this exercise. Or if it doesn't, it could be outside the scope of what we're trying to accomplish right now. Plus, I want to err on the side of shipping software rather than analysis paralysis. And really, this is the whole happy path, right? If nothing goes wrong, this is essentially what needs to happen. So if we write these tests, we'll have a North Star to guide us as we sail along and seas get choppier. If we ever make changes and these tests fail, we should probably do some rethinking. Our new tests will be preventing our own regressions. That's just another reminder that the next developer to work with your code can be ourselves, even just an hour later. So should we write some tests? Okay. Before that, I'm also not here to introduce or debate the different methodologies for writing individual tests. That's another talk or workshop, and they mostly all boil down to some variation of given, when, then. All right, what might test code for this portion of our rigging look like? Let's start with the setup. We know we need a pirate whose information is going to be updated and whose ID will be part of the URL based on Rails RESTful conventions. And now the action, we already said, that's going to be when the user submits the form data. So if we use RSpec's request syntax, it might look something like this. And eventually our expectation, that it should redirect. Here we are with test code for both it blocks from before, redirects to the user's show page and updates the database. Now we've got some wind in our sails. We've understood our flowchart as a context, and still, at just one path, our given is the matching setup. The action that begins our flowchart has become the when. That's the action taken in our test cases. And we've identified the two end states, one for the HTTP response and one for the database. And we've captured them as then in the expectations. So as I'm building out a system, I'm trying to uncover moments where we might be taking something for granted, an assumption that we've built on top of that isn't as guaranteed as we're treating it. So I'm asking myself, what here is built on a lie? What here could go wrong? And my eye is drawn to this. These params are sent in by a user. You know users, so do I. And I don't trust them. They always find interesting ways to stress a system. Brand new ways to use our software that we never even dreamed of. In reality, though, that's a gift. It really is, and I believe that. But right now, it's a problem. So far, our tests are assuming that everything is going to go smoothly. We need to handle what happens when the params don't pass validation. So let's fold up the test code like we're in our editor and add this params protection. What would params that don't pass validation change about the flow of this chart? Right? That change will never make it to the database. And because that can fail, we need to add to the flowchart before the persistence a check for validity. We'll notate this fork in the road with a diamond because in Flowchartland, which is a province of Diagramopolis, a diamond represents a decision. Something in the setup or the action that is affecting the outcome, the value of which decides the branch of the flow to continue down. And now we truly have more than one path through the feature, and with it, another context that needs testing. Let's trace the two paths so we can see what we're dealing with. If a path is a context, we're able to tell that one context is separate from the other. The nodes in the flowchart that are reflected in the rigging as existing specs can't be reached by that new path. They're an entirely different context. Let's reflect that in the rigging. But how can we know what that context involves? It's not as simple as an endpoint. There isn't one node in the flowchart that equates to context, but many along a path. So let's ask ourselves a question. What setup or initial input will cause the decision to go to the right, where we see the two it blocks that we already have? Valid params, right? And then the opposite, invalid params, causes the flow to go to the left. And the it block, based on Rails conventions, will render the edit page again and send the object over to the view with those validation errors attached. So let's act on these tests in the flowchart as we have it currently. What do we want to do next? Personally, I'm not going to feel good about these tests until I see them fail. We haven't written any code for them yet, so if they pass, there is definitely something fishy going on. Great news, the test failed. That means we can write some code to make them pass. We're going to keep this as simple as possible, but let's think about the code that we'll need in order to follow the flowchart and satisfy the tests. We'll need to know which pirate. If the update works, we'll redirect. And if not, we'll render edit. Nothing fancy here. This is direct from Rails generators, maybe condensed a little for slides. But how did our tests fare? Nice. Good work, everybody. Let's just take a moment to reflect on how we got here. We used the ticket requirements to make a simple flowchart that met the user story, the happy path. And from that flowchart came our test rigging. We wrote some tests and uncovered a failure state, which led us to expand on our flowchart and rigging. And from there, we used our understanding of the system at play to write the application code. Chart, rigging, test, chart, rigging, code. All that is to say that this process isn't going to be linear most of the time. Usually we won't have written the whole entire flowchart with everything in scope, then move on to the entire rigging, then the test code, then the app code. We'll bounce around, acting on the next bit of information that we're confident about, uncovering assumptions as we go, and adding to our framework in the process. Well, we don't really have everything that's in scope, do we? Remember that there is a second acceptance criteria. Number one, we already have. We can update a pirate's profile info, but 2 here says that only authorized pirates can perform updates. So before our check for validity, in the same way that we added the valid step before persistence, we have a new step that can interrupt the process before reaching the end states that we had charted before, which leads to another path through the chart. Now, ignore for now the implementation of even having a logged in user. I've only got, well, actually I got 11 and a half more minutes with you, but no. Another path should make us think, what? Another context. Using the same technique that we did before, we can wrap the expectations based on when their paths diverge. The first time any paths diverge, they go in 2 different directions, green to the left, blue and orange to the right. So that tells us that there will be 2 contexts. And it's the decision where they branch that tells us what that context is. Authorized, no. That's green. And because the other paths share the state of a pirate that has permissions to change this data, the context about being authorized will wrap them both. But we've done this kind of exercise before, earlier. Why bring it up again? Because I want to throw a metaphorical match in our powder keg. Turns out, what makes someone authorized isn't so cut and dry. Authorized, yes, no, is perfectly fine for the flowchart here because at the controller level, that's the flow of this action. But to be authorized, well, the logged in pirate is either the pirate being changed or a pirate with the admin role. What was once 3 paths through the chart is now 5, and if we reflect that in the test cases, we go from 4 to 7. That's 57% more tests. And I like tests and all, but conceptually, this doesn't feel too much different from what we already had. We added this section, but it makes the same decision. Authorized, yes, no. It's just a more complicated process. Maybe you're already standing where I'm leading you, or maybe you're on the way, but if this box was opaque, and all we saw was authorized, yes, no, then the rest of the paths would have the same information and the same flow, right? Does the pirate controller really need to know how to tell if a pirate can make the change, or does it just need to know whether to make them walk the plank or not? It's the latter, right? So let's encapsulate that logic in an object. Look at this. Robert Louis Stevenson and Sandy Metz back together after all this time. And because we can test the authorization logic over in this object's tests, some might even call it a service object, it doesn't have to be part of our controller test at all. We can mock the call to the service object within the test, force it to say yes or no, all a part of our setup, and suddenly we're back with just authorized yes, no. And the next time that you're looking to encapsulate some logic away in a service object, look for parts of your flowchart where those paths go apart. Do something self-contained, but then converge back together like we did here. But if we think about it, we already have similar nodes in this flowchart, don't we? Right there. This isn't a single thing. This is active record taking our params hash, doing something with ARL, spitting out SQL, traversing to a database, which is a whole different program, updating a resource. Can you imagine the flowchart on that? An active record just handles it, so we can put a single box in our flowchart. In the same way that we zoomed in to get to an authorization service class, and we understand the zooming we could do behind the persist node, we can also zoom out from our controller. Up until this point, we've been looking at a single action, and everything else happens like dominoes without our influence. This is a flowchart for ordering a book from Amazon. This is very high level. It's really zoomed out. It's all the way to the user. Everything is abstracted away. They're not thinking about HTML, servers, databases, none of it. And yet, this is an incredibly useful diagram, even for testing, even for writing code. In the same way that our happy path tests were our North Star while building and refactoring, something like this can be the North Star for an entire business or development team, able to ask themselves, can a user still order a book? Or does this help a user order a book? Probably not Amazon anymore, because nowhere on here do I see shoot founder into space. I also don't see let him come back either, but we did that. Each of these purple blocks is an action by a user. Sign in, add to cart. Each and every one of them probably could be its own controller action if it was Rails, each with its own flowchart as intricate, but probably more so than the one that we just built. But at this level, this can a user order a book level, those aren't important, for the same reason that it wasn't important to our controller if the user was an admin or a specific pirate. Still, each branch or each flow is going to need a test. Maybe at this level a context, maybe not, again, personal preference, but I see 5, 6 tests here. Eventually, every purple box reached by the path of a test from start to end. So I hope that helps you see that there aren't rules on how to do a treasure map technique, but some ideas and advice on how you might be able to apply it in your own work. I literally do this in my work. This is a commit message I wrote last week. That's right, I know. I put the flowchart in the commit message. And if you too want your commit messages to bring all the boys to the yard, the tool I use to make this plain text flowchart is ASCIIflow. That's ASCIIflow.com. So yeah, take these ideas, use them, throw away what isn't working, add on where it falls short. Oh, okay. And if you do add on or do something cool with it, please tell me on the Twits, the Gram, GitHub, any of these things. I'm around. I would love to know how you remix this or adapt it to other frameworks and languages. Let's open source this thing, right? Because we might be here under the auspices of landlubbing rails rather than ocean waves. I can, without objective, see whether your features be crafted of ruby, emerald, carved of elm, adorned with jade and pearl, or crusted in rust. This elixir flies truthy as a dart for all those who sail the sea from Java to Ceylon. In lieu of more formal language, and you might consider it basic, but even through a common lisp, I won't be hearing any small talk, because this ship to be swift as an camel traveling the mighty Gobi desert. But to give, I am particularly proud of that one, but to give this here groovy assembly some unity and closure, let me be crystal clear with ye. I'll go to Davy Jones's locker and bash a 100-foot python before I give up me test-driven development. And now that you've seen the ample scale of this technique, I hope your acceptance criteria ever be clear. Your test suite not scuttle your deployment, and the cloud never take the wind out of your sails, so that the good ship, Capybara, can see you home. Thank you.